the course Data Structures. Today topic is Stack Data Structure. What is stack? Stack is an abstract data type with a predefined capacity. That is, the capacity is limited. It is a simple data structure. It allows adding and removing an elements in a particular order. And also, stack follows the principle LIFO, last in, first out. What it means? Every time an element which is inserted, it goes on the top of the stack. The only element that can be removed is the element that was at the top of the stack, just like a pile of objects. That is, the last inserted element into the stack, it will be deleted first from the stack. Better, the more applications for stack, balancing the symbols, that is balancing parentheses, evaluate infix expressions to postfix expression, evaluating postfix expression, and then towers of Hanoi. There are two operations we can do with stack, push and pop. Push is an operation which is used to insert an element into a stack. Pop, which is an operation which is used to remove an element from a stack. Both insertion and deletion can be performed at one end of the stack. That end is called top. Here I show you one example how to insert an element and how to delete an element from the stack. So initially the stack is empty. Here the stack which has size 2 and also the top pointer which is initially pointing the location, that is size -1. Here the empty stack with size 2, the top pointer which points the location -1. So when I want to insert an element, that is push 10, the top pointer will be incremented and will point the next empty space in the stack. After that, the element 10 which will be inserted at the space where the top is pointing. That is, insert an element at the top of the stack. Second, because the stack size is 2, so now I'm going to insert another element 20, push 20 into the stack. For that, first I have to check whether the stack is full or not. If the stack is full, then I cannot insert an element 20 into the stack. This is stack overflow. So definition for overflow is I'm going to insert an element when the stack is full, which cannot be done. So that is called as stack overflow. So here I want to insert an element 20. First I have to check the stack is full. Here the stack is not full, so the top pointer will be incremented to the next empty space, just like in this top, which will point the space above the 10. And then I just add an element 20 to the space where the top is pointing. Right. Okay. So next operation is pop operation. Pop operation which is used to delete an element from the stack. The current stack which have two elements 10 and 20. So the order we have inserted is first 10, second 20. So the last inserted element is 20, so which is pointed by the top. So now I'm doing pop operation, then the removed element from the stack is 20 and also from the top of the stack. Okay. So next I just decrement the top pointer below, that is 10. I just decrement it. Okay. So when I'm trying to delete an element when the stack is empty, which comes under the condition underflow. The definition is when I am trying to delete an element when the stack is empty. So that is known as underflow. So both push and pop operation we have to check stack is empty for pop operation, stack is full for push operation. Okay, so this both operation we can be implemented in the stack, and also array can be implemented in both arrays and linked list. So now I have explained an example with the array stack. So I hope you can understand both push and pop operation from this video. Thank you.